All right, straight to the point. Number 10, solar sails. In August 2024, NASA's Advanced Composite Solar Sail System, ACS-3, built at Langley Research Center, deployed an 80 square meter sail from a spacecraft the size of a toaster oven. No engine, no fuel, pushed by nothing but photons. The sail had been compressed into a CubeSat frame for launch, then unfurled in low Earth orbit on booms made from carbon fiber composite, lighter and stiffer than any metallic structure previously flown. The mission confirmed deployment. It worked. This wasn't new territory. Japan's Ikaros spacecraft confirmed solar radiation pressure in 2010, measuring a continuous thrust of 1.12 millinewtons as it flew toward Venus. The Planetary Society's LightSail 2, in 2019, became the first spacecraft to raise its orbit using sunlight alone. At JPL, physicist Slava Turashev has proposed a solar gravitational lens mission, only the third project in NASA history to receive NIAC Phase 3 funding, $2 million. That would use a sundiver maneuver to reach 550 astronomical units in under 30 years. But the number nobody reads past the press release is the one that should stop you cold. The engine is photons, light that left the sun 8 minutes ago. That is the propulsion system. In the sundiver variant, where the spacecraft dives toward the sun first, picks up speed at closest approach, then unfurls the sail in the most intense radiation it will ever encounter. Exit velocities exceed 300 kilometers per second, 15 times faster than Voyager 1, faster than any object humanity has ever launched. And still, at that speed, Alpha Centauri is roughly 4,000 years away. The light that left before we arrived is all we have. This is the most flight-proven interstellar propulsion technology in human history. It has been tested. It has been confirmed. It is flying right now. And it will not get us to another star in any human lifetime, nor in any civilization's recorded history. The most advanced propulsion system humanity has flown toward deep space runs on sunlight. And that should terrify you, because it means the stars are exactly as far as they look. Number 9. Laser sails. In January 2025, Harry Atwater of Caltech's Kavli Nanoscience Institute published the first ever direct laboratory measurement of radiation pressure on a light sail membrane in Nature Photonics. 2 months later, Miguel Bessa at Brown University and Richard Norte at TU Delft published a sail design in Nature Communications, 200 nanometers thick, patterned with billions of nanoscale holes, optimized by artificial intelligence, fabricated in 1 day. A sail thinner than most viruses, built in a single afternoon. In 2016, Yuri Milner pledged $100 million to Breakthrough Starshot, a project to accelerate gram-scale probes to 20% of light speed and reach Alpha Centauri in 20 years. Approximately $4.5 million was spent before the project went on indefinite hold. What makes this particularly unsettling is not the physics. It's what we're actually sending. The concept, a ground-based laser array, 100 gigawatts, covering roughly a square kilometer, fires at a fleet of 1,000 spacecraft, each weighing a few grams, each attached to a sail a few meters wide. 10,000 times Earth's gravitational acceleration, sustained for 10 minutes. Then silence. Then 20 years of coasting. The probes enter the Alpha Centauri system at 20% the speed of light. They have no braking mechanism. They pass through in hours. There is no second opportunity. At that velocity, even the stray hydrogen drifting between the stars, roughly 1 atom per cubic centimeter, strikes the sail with the energy of a particle accelerator. The void becomes shrapnel. 1,000 probes are launched because the models suggest most will not survive. It is, in the precise engineering sense, a shotgun aimed at another star. The fastest spacecraft ever proposed by physics costs less than a car, because anything heavier never survives the trip. Number 8. Nuclear pulse propulsion. Between 1958 and 1964, a classified program at General Atomics called Project Orion investigated a spacecraft that would detonate nuclear bombs behind a steel plate and ride the explosions. The lead engineers were Ted Taylor, one of the most gifted bomb designers in American history, and Freeman Dyson of the Princeton Institute for Advanced Study. In November 1959, a subscale model called Hot Rod flew to 100 meters using sequential chemical explosions. It worked. That model is now in the Smithsonian. In 1973, the British Interplanetary Society began Project Daedalus, a design study for a fusion pulse interstellar spacecraft to reach Barnard's star in 50 years. The lead engineer was Alan Bond. The team worked 10,000 hours across 5 years, much of it in a London pub called the Mason's Arms. The truly horrifying aspect isn't that it worked, it's that it worked in 1959. Freeman Dyson calculated that with Apollo-era funding, Project Orion could have delivered 150 people to the moon and launched crewed expeditions to Mars and the moons of Saturn. Not in some distant future. In the 1970s. With technology that existed in a decade when humans still navigated by paper maps. The program was not canceled for engineering reasons. It was not canceled because the physics failed. It was canceled by the Partial Test Ban Treaty of 1963, which prohibited nuclear detonations in space. The same treaty that ended the arms race ended the Starship. Carl Sagan once proposed repurposing the entire Cold War nuclear arsenal, enough warheads to end civilization, to instead send a colony ship to another star. The warheads still exist. The proposal does not. Humanity had the engine. We signed the treaty. And now we call it a thought experiment. Number 7. The Bussard Ramjet. In 1960, Robert W. Bussard of Los Alamos National Laboratory published a proposal in Astronautica Acta for a spacecraft that needed no fuel tank. It would project a magnetic funnel ahead of itself, scoop ionized hydrogen from interstellar space, compress it into a fusion reactor, and accelerate indefinitely. In theory, the faster it moved, the more fuel it collected. Relativistic speeds were, in principle, achievable. In 1988, Robert Zubrin and Dana Andrews demonstrated that the scoop would generate more drag than thrust. In 2022, Peter Schachtschneider of TU Wien and Albert A. Jackson published a definitive reanalysis in Acta Astronautica. To collect enough hydrogen to be useful, the magnetic funnel would need to stretch approximately 150 million kilometers from end to end, the distance from the Earth to the Sun. The implication nobody wants to say out loud is that the most elegant interstellar engine ever conceived makes you slow down. The interstellar medium holds roughly 1 hydrogen atom per cubic centimeter. That number is not nothing, but it is close. To compress enough of those atoms into fusion conditions, the magnetic field would span a region larger than the distance between Earth and the Sun, and it would need to be sustained for every moment of the journey. The engineering required would exceed anything civilization has ever constructed for a machine that, in the end, decelerates its crew. The concept's greatest scientific contribution turned out to be its failure. Zubrin recognized that the magnetic scoop, reversed in polarity and aimed at a destination star's stellar wind, functions as a perfectly elegant brake. The mag sail. It works beautifully as the one thing the ramjet never could be, a way to slow down when you arrive. The universe offers you infinite fuel. It just doesn't let you use it. Number 6. Fusion propulsion. In December 2022, the National Ignition Facility at Lawrence Livermore National Laboratory achieved nuclear fusion ignition for the first time in history. The fusion reaction produced more energy than the laser energy delivered to the target. By April 2025, the record had been surpassed. 8.6 megajoules released at a target gain exceeding 4. 11 successful ignition experiments to date. Meanwhile, at Princeton Plasma Physics Lab, Samuel Cohen's PFRC-2 reactor, roughly the size of a minivan, sustained electron temperatures exceeding 500 electron volts and produced surplus electrical power simultaneously with thrust. In March 2025, at the Spacecom Expo in London, the British company Pulsar Fusion unveiled the Sunbird, a nuclear fusion rocket developed in total secrecy for 10 years. But here's where the numbers become genuinely strange. The NIF ignites fusion using a capsule of fuel smaller than a peppercorn. The direct fusion drive at Princeton outputs 2 megawatts of electricity as a byproduct of thrusting, enough to power a small city block, generated inside an engine the size of a cargo van. The Sunbird would be the fastest self-propelled object ever built, projected top speed of 329,000 miles per hour. Here's the counterintuitive fact that professional aerospace engineers have noted. A fusion rocket is actually easier to build than a fusion power plant. A power plant requires continuous, sustained ignition. A rocket only needs short pulses, bursts of plasma directed out a magnetic nozzle. The bar is lower. The fuel exists. The ignition physics has been confirmed. What remains is engineering, not discovery. We just ignited a star in a laboratory 11 times, and we're still calling it a prototype. Number 5. Generation ships and human hibernation. In 2025, the Initiative for Interstellar Studies published the Chrysalis, a generation ship design led by researcher Andreas M. Hein. Chrysalis is a rotating cylinder 58 kilometers long, carrying 1,000 people for 250 years. NASA's 2024 NIAC program selected the STASH project, developed by Fauna Bio and Bioserve Space Technologies, to conduct the first animal hibernation trials aboard the International Space Station. At the University of Maryland, surgeon Samuel Teicherman has been running clinical trials of emergency preservation and resuscitation, cooling trauma patients to between 10 and 15 degrees Celsius, stopping the heart entirely and holding them there for up to 2 hours while surgeons repair otherwise fatal injuries. In controlled animal trials, 12 of 14 subjects survived with no detectable brain damage. What makes this particularly unsettling is that the people who leave will never arrive. The crew of Chrysalis who depart will not be the crew who land, not their children, not their grandchildren. The voyage would require approximately 8 to 10 generations, depending on the propulsion system. Every person born aboard the ship was placed there without consent. They have never seen a horizon that wasn't curved. They cannot leave. They will die inside the vessel, in space, between the stars, never having known the destination they are carrying their children toward. The hibernation alternative, suspended animation reducing metabolism to near zero, is no longer purely theoretical. The question of whether human beings can be cooled below 10 degrees Celsius, held in metabolic arrest for years rather than hours, and revived without neurological damage is an open engineering problem, not a closed biological impossibility. A 2022 study in Science confirmed that hibernating ground squirrels recycle nitrogen from their own urine into protein through gut microbes, preventing muscle loss during months of stasis. The biology already knows how to do this. The biology already does it. The longest journey in history begins the moment the first child is born who did not choose to take it. Number 4. Antimatter Propulsion. In November 2025, the Alpha collaboration at CERN reported trapping more than 15,000 atoms of antihydrogen in under 7 hours, a 10-fold improvement over any prior record, published in Nature Communications. In March 2026, the base step experiment at CERN transported antiprotons outside a laboratory for the first time in history, loaded into a 1 cubic meter superconducting trap, placed on a truck, and driven for 30 minutes. The goal is eventually to transport the antimatter 8 hours to a facility in Dusseldorf. Gerald Jackson, a physicist who formerly worked at Fermilab, has published NASA NIAC-funded mission architectures proposing that 590 grams of antimatter could propel a probe to Proxima Centauri at 10% of light speed. But here's where the nightmare begins. Not in the physics, but in the arithmetic. When 1 gram of matter meets 1 gram of antimatter, they annihilate. Every atom. 100% mass-to-energy conversion. The release equals the Hiroshima bomb. That is the fuel density of antimatter. A nuclear weapon per gram derived from E equals mc squared, and there is no fuel in the universe that exceeds it. All of humanity, every particle accelerator ever operated, every facility ever built, has produced approximately 20 nanograms of antimatter across the entire history of physics. That is not enough energy to boil a cup of tea. The current estimated cost of production is $62.5 trillion per gram. CERN drove antiprotons around a parking lot in a truck in 2026, and that was considered a milestone. The gap between what exists and what an interstellar mission requires is not a gap. It is an abyss with no visible bottom. The most powerful fuel in the universe exists. We just can't make enough of it to light a match. Number 3. Digital consciousness. In October 2024, the Flywire Consortium, a collaboration between Princeton, the MRC Laboratory of Molecular Biology in Cambridge, the University of Vermont, and the University of Cambridge, published 9 simultaneous papers in Nature presenting the complete adult connectomy of Drosophila melanogaster, 139,255 neurons, more than 50 million synaptic connections, mapped in full. Philip Hsu, formerly of UC Berkeley and now at Eon Systems, built a computational model of the entire fly brain and ran it on a standard laptop. The model predicted the fly's motor behavior, walking toward food, stopping to groom when particulate matter touched its body, resuming eating. With 91 to 95% accuracy, No behavior was programmed. All behavior emerged from the structure of the connectome alone. Anders Sandberg of Oxford's Future of Humanity Institute places 50% confidence on whole human brain emulation being achieved by 2064. The truly horrifying aspect isn't the technology, it's what it means for the thing that travels. A biological human being aboard the fastest spacecraft humanity could realistically construct would take approximately 75,000 years to reach Alpha Centauri. A digital human, a computational model of a brain loaded onto a gram-scale laser sail chip, would arrive in 20 years. The math alone makes the conclusion nearly inevitable. The human brain contains 86 billion neurons. The fly brain contains 139,255. The gap is 600,000 to 1. That gap is not permanent. It is a timeline. Consider what it means. The copy that arrives at another star will remember leaving. It will remember your face. It will remember what you decided to upload and what you chose to leave behind. And you will still be here, alive, unchanged. Two versions of the same mind, separated by 4.37 light-years, each certain it is the original, neither able to prove it. The most efficient way to send a human to the stars may be to stop sending humans. Number 2. The Alcubierre warp drive. In 1994, Miguel Alcubierre of the National Autonomous University of Mexico published a paper in Classical and Quantum Gravity showing that a region of spacetime could be made to contract ahead of a spacecraft and expand behind it, carrying the vessel at any speed, including faster than light, while the occupants experienced no acceleration whatsoever. In 2024, Jared Fuchs, Christopher Helmerich, Alexei Bobrick, and Gianni Martire published a revised solution in the same journal. The first warp drive geometry satisfying all classical energy conditions using only ordinary, positive energy matter. Harold White of the Limitless Space Institute conducting DARPA-funded research on Casimir cavities. Nanoscale gaps between metal plates that generate measurable negative energy density via quantum fluctuation discovered that a particular nanostructure produced an energy density distribution matching the cross-section of an Alcubierre metric. That year, the team released Warp Factory, open-source software publicly available on GitHub for designing and testing warp drive geometries. What nobody tells you about warp drives is that once you're inside one, you can never steer it. The energy requirements of the Alcubierre metric dropped by a factor of 10 to the 50th power between 1994 and 2024 through pure mathematical refinement alone. The original calculation required the mass energy of the observable universe. Current positive energy solutions require something closer to the mass of a large spacecraft. The optimization happened in equations, not in laboratories, which means it could continue. But at superluminal speeds, a causal horizon forms around the bubble. No signal from inside the bubble can reach the front wall. You cannot communicate with the leading edge of your own drive. You cannot steer. You cannot stop. You feel nothing. Perfect stillness. A pocket of flat space-time, while the universe bends around you, in a direction and at a speed you cannot alter, toward a destination you set before you departed and cannot revise. We just proved a warp bubble can exist with real matter. We have no idea how to turn it off. Number 1. Wormholes. In 1988, Kip Thorne of Caltech, who would receive the Nobel Prize in Physics in 2017, published the first mathematical solution for a traversable wormhole, a bridge through space-time that a human being could theoretically pass through. The research began because Carl Sagan, writing his novel Contact, called Thorne and asked whether a scientifically defensible faster-than-light transit mechanism existed. The answer Thorne sent back became a branch of physics. In 2013, Juan Maldacena of the Institute for Advanced Study in Princeton and Leonard Susskind of Stanford proposed the ER equals EPR conjecture. That Einstein-Rosen bridges, wormholes, and quantum entanglement are not two separate phenomena. They are the same phenomenon, described in two different languages. In November 2022, Daniel Jafferis of Harvard and Maria Spiropoulou of Caltech used Google's Sycamore quantum processor, 9 qubits, to simulate the dynamics of a traversable wormhole for the first time, published in Nature. The implication nobody wants to say out loud is that the shortcut already exists, and has existed since the beginning of everything. If ER equals EPR, then every pair of entangled particles in the observable universe is connected by a Planck scale wormhole. every photon that has ever been measured entangled with another, every particle that has ever interacted. Susskind has stated that entanglement sews space-time together. That without these connections, space would not hold its shape. It would atomize. The fabric of reality may be a web of microscopic tunnels, threading through what we perceive as empty distance. Consider what this means for the motif running through this entire video. In Entry 10, photons pushed a sail. They were the engine, the primitive, patient force that moves matter across the void. Here, at the end, the photon is the connection itself. Every photon we have ever studied, every particle we have ever entangled, may have been threading wormholes the entire time. We were not observing the universe from the outside. We were using the shortcut to study the shortcut. The light that left before we arrived was never just light. It was the road. The fastest path to another star may not be something we build. It may be something we finally learn to read. If you want to see more videos like this, click the video on screen now and make sure to subscribe.